Virtualization is intertwined with the evolution of computing, going all the way back to the 1960s and IBM. A lot happened during this time period, and in this deep dive video, we shall cover how the evolution of computing eventually led to virtualization and the world we live in today. So it all started with the mainframe, or what we would consider supercomputers today. You see, in the 1950s and 60s, there was no concept of the internet or personal computers. There were just mainframes. And these mainframes were largely in labs for scientific purposes and government projects. This was, however, a great time to be alive if you were a mathematician, physicist, or an engineer. As in the 1960s, there was a huge drive for a new America. And if you had any of these skill sets, you could work for a company like IBM, who were leading the charge in electronic computers to help solve many problems across industries, from science, government, defense, etc., etc. Now, these mainframes were gigantic machines that often filled laboratories and rooms. And to put into context the processing power back then, despite filling out large spaces, these mainframes were not as powerful as your mobile phone in your pocket today. And to interact with these mainframes, you'd have to be on site, aka in the lab. And users, aka scientists, would have little consoles that would interact with the mainframe, but this is not to be confused with terminals and screens, which came later in history. As this video continues, we will discuss. But for now, imagine this user console device as a physical device with buttons similar to a typewriter, or what was known as a teletype. And imagine the connecting wire here being a conceptual idea. As we go through the video, I will explain it was not as simple as this. And nothing in history ever was. And this topic is further complicated given the literature and various computing evolutions that occurred simultaneously were not exactly linear. So please indulge me as I try to gather all the facts and my research into a very simplistic video. So, from my research, 1953 was a huge breakthrough in computing because the IBM 701 electronic data processing machine, also known as the Defense Calculator, was released for commercial business use, intended to solve all your computing and mathematical needs. This was revolutionary for the time and came with a lot of hype. Thus, not surprising that it rented for $15,000 a month. Even back then, that was a heck of a lot of money. And perhaps why that during 3 years of production, IBM sold 19 701s, mainly to research laboratories, aircraft companies, and the federal government. There was a lot of expectation, but that came at a cost. A big cost to solve all your problems. Another reason why the 701 was such a huge revolutionary breakthrough is if we rewind a few years back to what computing and the 701 evolved from, which was the 1950s punch card data processing. Think of punch cards a bit like typewriters on steroids. Because, as odd as it may seem today, commercial computers back in the day, 1950s to early 1970s, did not have keyboards or screens. This was because users didn't have direct access to computers. In fact, the term computer back then actually meant a human that would use this whole punch card system, aka the user. And the user would punch into a punch card the data or the instructions or the programming code that would be fed and read by the mainframe. And this was by physically taking out the punch card out of the punch card machine and then walking over to the mainframe and feeding the mainframe the punch card. Now, how the punch card and the punch card machines worked was very clever. In the absence of computer screens and proper processing systems and operating systems, punch cards filled that void. A punch card or punched cards were thick paper card that had holes punched into it by the punch card data processing machine, and each of these holes represented data. And there was some signs between the columns and rows that were printed on that paper, and where exactly the holes were punched, depending on the column and row, would represent some encoded data. For example, a certain hole in a certain row or column may represent a binary 0, or an absence of a hole may represent a 1. There was, however, some interesting limitations in how many characters could be printed on a punch card, but more on that in a separate video. So when a punch card was punched and a user, aka a computer, as the user was a computer in reference back then, which meant the user would have to walk across physically to what was a punch card reader machine and put the punch card inside that machine, which was connected to the mainframe. So you could say computing back then kept you fit and healthy. Now the punch card reader detects the holes and converts them into electrical signals representing data and then sends them to the connected mainframe over the wire, and this is where all the electronics happened. But until that point, there was a mixture of manual entering and manual walking to the punch card reader, and then the electronics from that point onwards happened. So you could say there was 4 stages, of which 2 were manual and 2 were transferred into electronic signals. And the last 2 stages between the punch card reader and the mainframe had an electronic wire, whereas the first 2 stages had human legs that walked with the punch card from one device to the other. So what happened once the punch card data was converted to electronic signals and sent to the mainframe? Well, the mainframe could store or process the converted electronic signals in its RAM, random access memory, or store it within its hard drives, which were magnetic tapes back then, or even store the output on paper format, physical paper, which was stored in physical cabinets, usually underneath the mainframe cabinet. But of course, as time passed, this system became old and a new way of working was needed where everything was interconnected with one wire or multiple wires rather than any use of human legs. And so future enhancements and technology were underway being created, and this was part of the overall 7000 series by IBM, of which the 701 was just one model, but other models would later be released, such as the 704, 709, etc., etc. And an important technical keynote to understanding this evolution was that punch card data processing was also known as batch processing, aka a one-off production of a load of punch cards sent to the mainframe at one time. This made sense at the time because only one user could use one program at one time, aka use the mainframe at one time. There was no concept of modern operating systems or even multi-programming back then. This meant only one user at one time could take their punch card or punch cards over to the punch card reader, which would then convert it and put it into the mainframe for processing, storage, etc. etc. But there were obvious problems or limitations with this one user approach. Can you guess what they were? Inefficiency? Wasted time? Yes, you are correct. As whilst one user gets their punch card data read by the mainframe, another user is waiting for that same user to hurry up. Oh yeah! What's worse is once one user finishes and the next goes over to the mainframe, this walking stage and wasted time in between is known as idleness, as the mainframe is waiting for the next user to enter their punch card, and this mode is known as idle mode, where all that fancy processing power of the mainframe is just sat there waiting, wasted, when it could be doing something else or processing another person's punch card. As time was maths back then and later became money, as this whole process and system evolved. And as this video continues, we will explain how this evolved and who the pioneer engineers were. But for now, I want to clarify a slight misconception. The IBM 701 was not necessarily one machine or a few machines. In fact, it was a heck of a lot of big machines, which took up a lot of space in a lab and later inside commercial businesses. So, in order to have a 701, you needed a lot of space in your business to store all these big fancy computing machines. And all these large components combined together to form what was known as the IBM 701, being a collection of different components, for example, the storage, the processing, the printer, the recorder, the fax machine, the punch card machine, etc., etc. So think of the IBM 701 as an all-encompassing term for all these components. And here is a fun history fact. The 701 was IBM's first mass-produced stored program computer. And now, to further contextualize and visualize what happened between this point and the next, let's draw this line where the bottom is the 1950s and the top is the 1960s. However, there was a lot of overlap in this period. From worldwide shifts in technology evolutions to new inventions to the internet, etc., etc. And from what we've understood so far, we can understand that the internal scientific labs in the 1950s then turned into external businesses in 1960s. And this was a critical period in the technology evolution. You see, the 701 was a launchpad for IBM to the world market and bringing computing to the mainstream. So much so that many clever futuristic concepts were being discussed by very clever academic people, including the concept of time sharing, which back then was the idea of multi-programming, aka the mainframe doing many tasks at the same time for many users. One pioneer in this space was Christopher Strachey, who was based in the United Kingdom alongside another pioneer in the United States known as John McCarthy, who was an interesting character in history as he's also dubbed the father of AI, artificial intelligence. But more on that in a separate video. And now, arguably the most important man in computing history, a revolutionary pioneer who almost predicted the future matrix back in the 1960s, and his name was J.C.R. Licklider, who put into practice what Christopher and John were describing as time sharing, and went one step further to promote a new idea known as interactive computing, an alternative to the old batch processing using the punch cards as described earlier in this video. This was a visionary concept and must not be understated how important this interactive computing concept was in the creation of keypads and digital terminals and screens and later even the internet. And this idea would eventually negate the need for the old punch card data processing systems and processors by making the computers technical devices rather than humans. And this involved more interactive programming, which involved using a teletype or other keyboard and getting immediate feedback from the computer without the user ever having to get out their seat and take the punch cards over from one machine to the other. What's more crazy is this teletype type device was already being used by Licklider whilst he was working at the Massachusetts Institute of Technology, MIT. This was what was known as the Whirlwind computer that had been operated at MIT, and it was essentially what Strachey and McCarthy had in mind back in the end of that decade. So Licklider, being the futurary visionary that he was, had a brilliant idea back in November 1961 and worked on a prototype time-sharing machine which had been produced and tested at MIT. And this in some ways actually made the first modern operating system that was needed to produce that type of concept of time sharing. So looking back in hindsight, that was a pretty big deal. And IBM were very aware and interested in this concept of time sharing, so much so that they would integrate or even patch into their IBM 709 Licklider's MIT time sharing prototype, which would connect three users at IBM Flexo writers, all typing away simultaneously at those Flexo writers. And so interactive computing was born and very much live, and the world was watching. If hashtags existed back then, and they might have done, this would have been hashtag interactive computing. Oh yeah. So to understand interactive computing, we need to understand interactive terminals, aka the teletype device. Think of a typewriter on steroids. Teletype devices were early interactive terminals and were largely electromechanical, but still used paper rolls for logging output. Eventually, over the years, these would be replaced by what we know today as computer screens for digital output. Crazy to think the screen you are watching this video on evolved from punch cards and teletype devices, which printed output on physical paper rolls, but now print it out digitally on your screen. God bless J.C.R. Licklider for this invention which we now take for granted. So, computer screens back then were known as glass teletypes, and the next evolution was creating wires and ports that would connect these glass teletypes to the mainframe or similar devices. And so the RS-232 serial connection was born, which essentially allowed for direct connections between terminals and mainframes, a huge step in computing evolution. But the visionary Licklider was already looking at the next big thing. But the problem was technology was still catching up to meet Licklider's vision. So in the meantime, Licklider was placed in charge of another project, this time for the US government, which was called the Advanced Research Projects Agency, ARPA. That's ARPA. which was created in response to the Sputnik satellite by the Soviet Union in 1957, as the race to space was on, especially with all this cool computing. After all, if money makes the current world go round, why not spend it on intergalactic travel? As solving the world's problems is one thing, but space, eh? Anyway, back on Earth, it is worth noting that there were many projects going on at this time around timesharing, but it was ARPA leading the way, and this further became evident with the creation of the ARPANET, which became the foundation of the modern internet today. Think ARPANET, internet, tomato, tomato, you get the idea. And to finish this section, just remember J.C.R. Licklider was an important person in computing history. Now, all that was a slight deviation, but a very important deviation in order to understand the rest of the IBM story. So let's pick off from earlier in the video. What happened after the IBM 701 was released and the world was fascinated with how the ARPANET and also terminals, interactive computing, and even early artificial intelligence, AI, yes, even in the 1960s, was all going to evolve and make the world a better place. Well, here's how it went. IBM dominated the market, especially the terminal display market for screens from 1965, with its IBM 2260 display terminal, aka CRT screen, which was the first screen that came with computers. And this made computer screens not a novelty but a luxury, and by 1981 CRT terminals were used all over the United States of America, with 10 million terminals installed. And with advances in computer screen terminal character printing, later referred to as ASCII terminals, this eventually ended the need for teleprinters and teletypers, as screens were very much the future, and the matrix had begun. Here's a fun fact. By the 1970s, IBM produced its first silicon memory chips to store data and instructions, and this produced amazing faster speeds, and so began the computing evolution towards faster, smarter, and smaller devices. And here's a fun history fact. The term Silicon Valley was first phrased after the silicon memory chips, which were used in the IBM System 370 release. And on the point of Silicon Valley, it is also important to remember there were many other big manufacturers in the mainframe market, not just IBM, during the 70s and 80s, and all of these were very important in the evolution of computing and in turn the internet. But for the purposes of ending the IBM history story, during this same period, IBM were also exploring the possibilities of virtualization of their mainframes, and this occurred from 1964 and continued all the way throughout history, aligning with various product releases. During this same period, another project was occurring at the MIT Institute known as Project Mac, which was building and evolving the concept of time sharing into an operating system, which then laid the foundation for what we know today as Unix or Linux. The intertwining of these two projects is very important and complicated, so I will make a part 2 video covering all of that to do it justice. But for now, I hope you enjoyed this video on the first part of the history lesson. Thank you for watching today's video. I hope you enjoyed the content as much as I enjoyed creating it. If you would like to see more content like this, it would be super fantastic if you could leave a like and subscribe to help support this channel's growth.